In this video I'm going to show you how to use a new MATLAB-specific API method called getDataAsColumns. Now there's an existing API method called getDataAsColumns that is not MATLAB-specific, but the one with the _m is MATLAB-specific. This one actually calls the non-specific getDataAsColumns. So the idea here is that in a hyperlith simulation we have in the hyperlith simulation we have a bunch of results here as usual, and if we want to get the CD, let's just put all the data. Let's send this to the list. So this is all of the CD data as zero-dimensional data series. So if I plot one of these, it's just a single value. It's a 1 by 1 by 1 data series. So in this case, all of the CD data is sent to the list as zero-dimensional data series, and each data series has a description field that describes the variable state. So we've got threshold level, defocus, CD, pitch, chrome thickness, and the which metrology point, or the site variable. So when we do this in the GUI, let's look at our API script here. This is in MATLAB, or in this case I'm using Octave on Linux. So we connect panoramic, we load the setup, we simulate, and then we get data series. We're getting the imaging.cd. Okay, so that is exactly, we're going to get handles to all these data series here, right? It's exactly as if we went into the list and sent this to the list, or we went into the output tree and we sent this CD data to the list. We're going to get handles for all those data series. Okay, and then we're going to, instead of using hyperlith to process this or reorganize this data, we're going to just immediately convert it to a matrix of data for MATLAB, and that's going to contain the headers, which is the column headers, which is basically the variable names, and then the data, which is the variable values and the data series values. So if we go to our Octave here and we run test, okay, and then we say whose, we should see headers and matrix 1. Headers and matrix 1. Headers 1 and matrix 1. So headers is the column headers, which is level, that's the threshold level, the defocus, the CD variable, the pitch variable, the TCR, and the site. So those are the names of the columns. So now let's say matrix 1, and there's your data. So the first column is the threshold level, or the level. The second column is the CD, I mean the focus. Third column is the CD. The fourth column is the pitch. Fifth column is the TCR, the chrome thickness, and this is the site variable. And then the last column, this is the value, the CD. So now you've got the CD versus all of these variables. All right, now the situation is just the same as if we were fetching 1D data. We were fetching 0D data, which was the CD, but now let's get the 1D data out. So let's just look at the GUI to see what we're doing here, to visualize. Let's suppose we're getting the aerial images. Let me send these to the list, and I'll get all of them there. I'll send all this data to the list. Okay, so I've got a bunch of aerial images. Now the thing that's different here is this is 1D data, and in this case, if I plot it, we get some kind of image, and it's versus x. So when I break this into column format, I'm going to get an intensity for every value of x. Now we're going to have a problem. Because we have different pitches, see here's pitch 200, and then here's pitch 250, and here's pitch 400. The problem is that these data series have different amounts of x values. This has 56 points, and this has 48 points, and this has 96 points. So if I try to get that in column format, I'm going to end up with a problem, because that routine is expecting that all of the data series have the exact same size. So we'll only be able to do this for one case, for pitch of 250 or pitch of 200, whatever, just for one value of pitch. So that's no problems. Let's see how we would do that in the GUI. We would say, just get me the case for pitch 250. Okay? So now we have data series which are all one-dimensional, but they're all the same size. See, we've got pitch 56. They're all the same size, and we can, we can plot them all on one plot. They all have the same number of samples. That's easy to do. They're all the same size and shape. So in the API now, let's see the equivalent. So get data series handles for output, and we're getting the aerial image, and we're getting it for the case of pitch equals 250. So this is equivalent. Once again, this command is just like in the API, going to the tree and saying, get me my aerial image and just the case 250. So now we have a bunch of handles. We have a bunch of handles to 1D data series. And then we're going to say, get data as columns underscore M, which is the MATLAB specific one that returns a headers, which is the column headers, which is the variable names. And now that will contain x, because the intensity versus x will be broken down, and x will be a variable. And then matrix is the data, matrix 2. So back in Octave, let's look at headers 2. So chrome thickness, CD, defocus, x, because it was intensity versus x, and the pitch. And then the matrix 2 looks like this. So there's your chrome thickness, your CD, your focus. This column is your x position, and this is your pitch, and this is your intensity. So this is intensity versus all these variables. And so this is at x equals 2.2, this is x equals 6.6, x equals 11, and that's your intensity. So it takes 1D data and breaks it down into a column format also, just like it took the 0D data. Now, I'm not suggesting that that's the way you should do things. Some people just like to work in MATLAB. But I think you should take advantage of all of the power in Hyperlith and work as long as you can with handles to data series. You can redimensionalize them, you can plot them, you can make measurements on them, you can do operations on them, all within the framework of Panoramic's API. But some people just simply like to get the data as soon as possible and work with it themselves. And that way, that's how you do it. Okay, so good luck.